We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
One small step for man, one giant leap for mankind.
Hello, greetings, and good day, and welcome to this episode of Space, the Final Frontier. This is your Kaspacer, Professor Jun Cajigal. Now, Space, the Final Frontier is a series of online lectures that is intended to inspire our students to love the sciences, especially astronomy. So, for this episode entitled SPACEFARERS, we shall look into the possibility of space colonization through traveling to and then living in space on a familiar location such as the International Space Station to various locations in space including the Moon, asteroids, Mars, and beyond. Also, this episode describes the serious physical, technical, and physiological challenges that will have to be overcome to have a vibrant presence in outer space. So if you have any questions or comments or reactions about this online lecture, please feel free to type in your questions or your comments or your reactions. Huwag po kayong mahiya and we would be happy to respond to your queries. So tara na and let us go where no man has gone before. Hello, greetings, and good day. So for our online lecture, we shall tackle the topic Spacefarers, Colonizing Other Worlds, how humans will settle the moon, Mars, and beyond. So probably to start our lecture for today, we must define first what a spacefarer is. Now, basically, a spacefarer is a person who travels into outer space. So, we are referring here to an astronaut or a cosmonaut. And we have been sending man into space for about 50 years now. It started with Yuri Gagarin when he orbited the Earth, and we were able to send man on the surface of the moon. And at present, we have humans working and living in the International Space Station. So probably the next step after that would be settling into outer space. Humans will eventually live and settle throughout outer space. So technically, in the future, we will colonize outer space. We will colonize the moon, Mars, and beyond. Now, it has been more than 50 years after the Apollo 11 moon landing, and still there is so little human presence in outer space. Will we ever go back to the moon again? Or will we ever reach Mars? Or what will it take to become a multi-planet species, colonizing the solar system and even traveling to other stars? So the question now that we need to answer is, why do we need to colonize other worlds? Why do we need to colonize the moon or even the planet Mars? Now, one motivation or rationale for colonizing other worlds would be spreading life throughout the final frontier. So just like in Star Trek, to seek out new life and new civilizations and to boldly go where no man has gone before. Now, another motivation for colonizing other worlds would be to ensure the longevity of the human race. Another motivation for colonizing other worlds is making money through varied forms of space commercialism such as space tourism. And another motivation is saving the environment of our planet Earth by moving those industries that destroy our environment in outer space. And finally, one motivation or rationale for colonizing other worlds is to ensure the supply of rare and finite material resources. So I hope you would realize the importance of space colonization. Our presence in outer space is limited only to the International Space Station. So my dear netizens, now is the time to go beyond the International Space Station and to pursue more advanced living in space. Why? Because colonizing the moon or even colonizing Mars can eventually increase the quality of life here on Earth. Now, there are several types of space colonies. So, one is a lunar colony or a lunar outpost, or popularly called a moon base. Then we have an asteroid colony. Then we have a colony, free-floating colony in Earth orbit. And lastly, we have a Mars colony. So here is a photo from the TV series Space 1999. So here is an example of a lunar colony or moon base as depicted in that TV series Space 1999. This is Moon Base Alpha. Alright, then we can also establish a colony on the surface of an asteroid. And we can also establish a huge space station in orbit around the Earth, or a free-floating space colony. And lastly, we can colonize Mars. We can establish a colony on the Martian surface. So for this lecture, we will be focusing only on establishing a lunar outpost or moon base. And also, we will take a look at the possibility of establishing a colony on the Martian surface. So, how do we establish a lunar base or a lunar outpost? How do we establish a permanent moon base? Now, when we speak of a lunar outpost, this is the concept of establishing a permanent or semi-permanent presence of humans on the lunar surface. Now, why do we need to establish a permanent or even a semi-permanent presence on the moon? Why? Because the moon is said to be the gateway to the stars. The moon is our first step in the exploration of some of the members of the solar system, like the planet Mars, or even Europa, one of the Galilean moons of Jupiter, or even Enceladus and Titan, in our search for extraterrestrial life. Now, the question is, what would we need to live on a lunar outpost? So, what are the requirements in order for us to establish a permanent outpost on the lunar surface? So we need the following: a habitat or shelter, we need power, food, water, earth communications, tools and equipment, and ways to move around the lunar surface. Now, in line with these requirements, in order to live on a moon base, what are the challenges in establishing a lunar base or a lunar outpost? So, we need to consider the following. Number one, the low gravity on the moon may have anatomically deleterious effects on the human body, such as osteoporosis, as experienced by the astronauts on the International Space Station. Also, we need to consider the lack of available water on the moon. Also, the absence of an atmosphere or magnetosphere on the moon. And the absence of the magnetosphere would mean that the lunar colonists are in danger of exposure to solar radiation. So there must be a way to protect our lunar colonists from solar radiation, because the moon has no atmosphere and the moon has no magnetosphere. Also, another challenge for the lunar colonists is the abrasive regolith on the lunar soil. Now, in the building of a lunar outpost or lunar base, a lunar outpost must be constructed in a relatively safe and flat location that is easy to reach on foot or by moon buggy. This outpost is really important in colonizing the lunar surface, because a lunar outpost is essential for long stays on the lunar surface. And in constructing a lunar base, the materials must be transported from Earth, which is quite expensive. But we can make use of lunar resources like regolith in coming up with lunar bricks. And a lunar outpost or shelter must be constructed underground in lava tubes in ancient volcanic areas to protect the lunar colonists from radiation from the sun, because as we mentioned earlier, the moon has no atmosphere and no magnetosphere. So the only way for the lunar colonists to be protected from radiation is by building the lunar outpost or moon base underground. Now, the lunar soil serves as a natural shield or barrier against solar radiation. So this is how a lunar habitat or a lunar outpost must be constructed. So the lunar outpost must be constructed underground so that the lunar colonists may be protected from solar radiation. So with the construction of these lunar habitats or shelter underground in order to protect the colonies from solar radiation, the question is, can the lunar colonists do botany on the moon? Can they grow plants on the moon? Now, the Chinese had sent a lunar lander called Chang'e 4. Now, this lunar lander carried a 3 kilogram or a 6.6 pound sealed biosphere with seeds and insect eggs in order to test whether plants and insects could hatch and grow together in a mutualistic relationship or synergy. Now, the experiment also included seeds of potatoes, tomatoes, and even a certain plant called Arabidopsis thaliana, which is a flowering plant, as well as silkworm eggs. So these became the first grown plants grown on the moon. So isn't that fascinating that the Chinese was able to achieve such feat on the lunar surface? Now, the environmental systems on board the Chang'e 4 will keep the container hospitable and Earth-like, except probably for the low lunar gravity. Now, if the eggs would hatch, the larvae would produce carbon dioxide, while the germinated plants would release oxygen through photosynthesis. We know that animals releases carbon dioxide, and the carbon dioxide would be absorbed by the plants needed for photosynthesis. Alright, so it is hoped that together the plants and the silkworms can establish a simple biotic relationship or synergy within that biosphere or container. And a miniature camera on board the Chang'e 4 will monitor and photograph any growth. So isn't that fascinating indeed? Now, if there would be positive results of the experiments on board the Chang'e 4 Chinese lunar lander, the question now is, can we construct or can we build glass greenhouses on the lunar surface like the one in the picture? Now, it would be impractical for lunar colonists to construct glass greenhouses on the lunar surface like the one depicted in this picture, because there is no way for the plants to be protected against solar radiation. Solar radiation will easily penetrate the glass panels and it would kill the plants. So the best way to do botany on the moon would be to construct those greenhouses underground, okay, for protection against solar radiation. And instead of lunar soil, the lunar colonists can make use of hydroponics as replacement for lunar soil in order for them to do their botany activities. Now, what about the power requirements needed to operate a lunar outpost or a moon base? Now, the power is in the form of fuel, and fuel is expensive to transport from Earth. So, the practical way for the lunar colonists to provide power is to make use of solar energy. Solar energy, solar power can be used to run a lunar outpost. So, the lunar colonists can install solar panels. These solar panels can convert the energy from the sun into electricity. Now, solar energy or solar power will have to be stored in costly batteries for long periods of darkness, unless the base is in a permanently sunny region on the lunar surface. So here is a picture of a lunar base with solar panels. These solar panels can convert the energy from the sun into electricity. Another option is for the lunar base to install nuclear reactors. Nuclear energy can provide an unlimited supply of energy to power a lunar base or a moon base. Now, aside from the need for power, what about the need for food in order for the lunar colonists to survive? Now, the food will be transported from Earth. But eventually, in order for the lunar colonists to be self-sufficient, the lunar outposts can make use of hydroponic gardens. These hydroponic gardens will have to be created in order to provide food for the lunar outposts. Also, there is the need for water. Now, liquid water does not exist on the lunar surface, but there is a possibility that water ice may exist in deep, permanently shadowed craters at the lunar poles. So, humans, the lunar colonists, they need water in order to survive. So, just like what they are doing in the International Space Station, the astronauts can filter and eventually they can also recycle water. So the lunar colonists can apply the same technology just like what they are doing in the International Space Station. And also there is a way in which water can be used as fuel. Water can be broken into hydrogen and oxygen and used as fuel or to create an atmosphere at the lunar outpost. So they can make use of fuel cells. A fuel cell operates by introducing hydrogen and oxygen in order to provide electricity for the lunar outpost. This technology was used by the Apollo spacecraft to power their computers and other electronics on board the Apollo spacecraft. Now, isn't that fascinating that the technology that was used in the Apollo program can be applied to a lunar outpost? Now, what about the need for communications? Now, we all know that the moon is about 240,000 miles away from the Earth, and we need to communicate with mission control. We need to communicate about outpost operations and the health of the astronauts. Plus, we want to stay in touch with our friends from planet Earth. So the outposts will have to be in constant view of Earth to maintain communications. If the outpost is not in view, costly satellite systems will have to be put in place. So we really need to communicate with mission control. Now, what about tools and equipment? Now, we will need to transport tools and equipment to the lunar outpost to build the base and to conduct scientific experiments on the lunar surface. Now, in line with the tools and equipment needed by the lunar outpost, the lunar colonists must also find ways of moving around the lunar surface as they build their outposts as they search for lunar resources and as they perform scientific experiments. So they need some form of a lunar rover or lunar vehicle like the one used by the Apollo astronauts as they explored the lunar surface. So the lunar colonists, they needed some form of a lunar rover like the one in the picture being developed by NASA, and this is a lunar rover that is now being designed by JAXA or the Japanese Space Agency. So those are some of the requirements needed in order to construct a lunar outpost.
Many years have passed since Eugene Cernan closed the door of the LEM behind him, closing forever also the epic of the Apollo missions. But at that time, it was not known that it would be forever. And on the contrary, there was a lot of talk about the future of space exploration, Mars, and the great bases that we would certainly have built on the moon by the end of the 1970s. Unfortunately, for many reasons, all of this has never been realized. But after half a century, it seems that the time has come to resume these dreams. So we are back to talk about lunar bases and to make plans for space exploration with human crews. Many projects have already been started and new competitors have joined the space race that has become mainly a race for mineral resources. Europe, China, India, and above all the big private companies, led by businessmen but also by brilliant visionaries. Once again, however, we are held back by political uncertainty, which heavily conditions the strategies to be adopted. So that one of the big questions of the moment, that if dragged on for a long time will risk to bog down again the whole sector, is that of better to bet on Mars or on the moon. To go directly to Mars or to implant first stable bases on the moon. What does humanity gain by building a lunar base? Today, the prospect of returning beyond low Earth orbit seems somehow more daunting, more dangerous than it did when the Apollo program ended. Perhaps we know too much now. Perhaps we are less reckless than we once were. We understand better what can happen out there. Space can kill us. But we have to go, and so we will go as always. Mars or the moon then? It's a strategic, political, and above all scientific choice. Many think or hope that the human journey to Mars can be accomplished by 2035. However, we are talking about a demonstration mission, a hit and run, if not even a flyby without the satisfaction of touching the surface. A bit like Apollo 10 did with the moon. But then a complete colony or even a very Spartan base to be planted on the red planet would take decades to accomplish. And perhaps the best way to learn how to do that is to practice on the moon. The moon is only 380,000 kilometers away and is, in the natural order of things, the first step in human space exploration. In fact, our natural satellite represents the first real opportunity for stable human settlement outside of the Earth's atmosphere. The International Space Station has had the very important task of consolidating our ability to operate, even for relatively long periods, in microgravity conditions and outside the atmosphere. However, to achieve a fully independent space outpost requires leaving low orbit and moving to the surface of another celestial body. The closest opportunity to us is therefore the moon, and the first fundamental step is to consolidate operations to our satellite. The exploratory missions of the 60s were dress rehearsals, demonstrations of technological capability, as well as operational, but they represent only a taste of the real challenge that awaits us: to ensure long stays on a celestial body different from ours, building settlements that can, one day, sustain themselves in total autonomy. There is, in fact, a fundamental difference between demonstrating the ability to go and return safely and permanently inhabiting a planet different from Earth. Creating self-sustaining settlements outside of our planet is the real goal that has never been attempted to date and implies the ability to reinvent the manufacturing process on another celestial body. That includes the extraction of raw materials and subsequent processing in situ. In addition to this, it should be added that the now confirmed presence of water makes extremely realistic the hypothesis of human settlements. Scientific research, of course, would certainly be one of the main objectives of a permanent settlement, but the effort would be primarily aimed at the development of technological capacity. In a long-term perspective, once developed the transport system capable of ensuring the connections Earth-Moon, the Moon could also become a sort of giant industrial zone, a place to decentralize the highly polluting production activities, lowering the negative impact they currently have on the Earth's ecosystem. In addition, because it has low gravity and no substantial atmosphere, the Moon is destined to become our spaceport par excellence. A lunar base could therefore one day ensure human and robotic expeditions to the edge of the solar system and beyond, and offer explorers the opportunity to learn how to live in hostile, low-gravity environments and test the technologies necessary for their survival. Typically, the establishment of a colony on a celestial body involves the provision of large quantities of materials for the construction of the base itself, as well as for other uses, including radiation shielding. The energy required to launch cargo from the Moon into space is much less than that required to perform the same operation from Earth, which will allow the Moon to serve as a construction site or supply station for spacecraft. The proximity of the Moon also gives other invaluable advantages when the project is to build something on the surface of another celestial body. Let's try to enumerate them together. A very short travel time. The astronauts of the Apollo missions covered the Earth-Moon distance in 3 days. Such a short time allows to both quickly send possible rescue missions from Earth and to quickly evacuate the crew of the lunar base. For comparison, the distance to Mars with current technology would require 6 to 9 months of travel, which would make any serious problems occurring inside the base lethal. The costs for the initial establishment of a base on the Moon would then be much less than for a colony on Mars, at least by a factor of 30. The telecommunications delay between Earth and the Moon is 1.2 seconds, which does not prevent normal voice and video conversations. For comparison, the delay with Mars ranges from about 8 to 40 minutes. This could be crucial in the early stages of colony establishment, where emergencies and critical situations could take advantage of near real-time assistance from Earth. An example of this was the Apollo 13 mission. On the near side of the Moon, the Earth appears large and always visible, while on Mars, when it is visible, it appears as a star. The crew of a lunar colony would feel psychologically less distant from Earth. A lunar base would be an excellent site for an astronomical observatory. Because of the Moon's slow rotation, observations in visible light could last for entire days. It would also be possible to keep a target under constant observation through a series of observatories distributed around the lunar circumference. A radio telescope on the Moon could be much larger than that of Arecibo because of the low gravity, and also the dish could be easily built inside a crater, simply by covering the cavity in aluminum. Moreover, the Moon is geologically dead. This, combined with the absence of widespread human activity, makes almost absent the disturbances from mechanical vibration, and therefore more efficient interferometry telescopes. Finally, it must be taken into account that on the Moon, there could be deposits of minerals considered rare on Earth, such as titanium, gold, palladium, iridium, and uranium, but also deposits of more common minerals such as iron, nickel, and aluminum. Not to mention water, available in large quantities in the form of ice polar regions, and not to forget that on the Moon was found helium-3, an element that could be used by nuclear fusion power plants, both terrestrial and lunar. However, this concerns a future still quite far, when we will be able to find a way to master the fusion process. If we want, the only disadvantages compared to a similar settlement on Mars comes from the force of gravity and radiation raining down from space. There is uncertainty as to how much lunar gravity, 1/6 of what we experience on Earth's surface and half of what we experience on Mars, is sufficient to prevent the long-term wasting phenomena of the human organism. Exposure to weightlessness for periods of time on the order of months has been shown to create a reduction in bone and muscle mass, as well as a depression of the immune system. Similar effects are produced by a low-gravity environment, although the only experimental evidence we have so far relates to zero-gravity environments. Daily exercise appears to be partially effective in preventing the effects of zero gravity. The absence of an atmosphere makes the lunar surface exposed to large temperature changes and radiation levels comparable to those experienced in the vacuum of interplanetary space, also increasing the risk of impact from meteors. Another small disadvantage compared to Mars is that the solar panels to provide energy on the moon are not effective. They can work only half the time. During the lunar night, everything is in the dark. It will be necessary to make use of small nuclear reactors, as the Apollo astronauts already did to provide power to their scientific equipment. But they were radioisotope generators, less powerful, while in the future it will be necessary to have real reactors. Apart from that, it would seem therefore a forced choice that of the moon, and besides barring a resounding about turn by the incoming Biden presidency, the road seems already marked by the political decision of Trump and the scientific decision of NASA to start Project Artemis, goddess of the moon and sister of Apollo, intended to bring a human crew onto the lunar surface in 2024. But fingers crossed. Too often we've seen a change of course in space policy due to a change in power. Moon with Bush, Mars with Obama, then Moon again with Trump. Now perhaps Mars with the moon as an intermediate step? Huge waste of resources, not to mention all the design energy burned on the altar of suspicious ideological differences. However, NASA has also started to theorize about subsequent missions, maybe for 2026, in which they foresee the use of a module to allow a short stay on the moon. But obviously that will not be considered a real base, a structure that we could have maybe in 2030, not before. The goal is the Artemis Base Camp, which will include new rovers, power generation systems, inhabited modules, and everything needed to support a view of the moon, including technologies capable of extracting water and materials. Once the base is operational, astronauts will be able to move to more remote regions of the moon. Whether or not they go to the moon or Mars, the years ahead will be filled with unprecedented adventures and scientific discoveries. This time, however, NASA and the United States will not only be the only players in the game. Space has now become a stage on which private investors such as SpaceX and Blue Origin are also moving, and likewise companies and agencies in other countries are beginning to invest in space infrastructure. China's space agency, for example, has shown clear interest in the moon, as have Europe, Russia, and India. All agree on the creation of permanent bases, initially in lunar orbit and then on the surface of the satellite. It is, however, not an easy task. The first problem is related to the fact that all participants in the lunar race intend to grab the same resource and the same places. For this reason, even today, the debate is essentially concerned not so much with the scientific aspects of the question as with the legal and commercial ones. For example, in all lunar programs, the area selected for the permanent base is the lunar South Pole. Although from a purely technical point of view, flights to and from the orbital station are easier to be made from the equatorial zone of the satellite. But just in the area of the lunar South Pole are concentrated the so-called cold traps, i.e. areas perennially in shadow covered with ice. And the beauty of the whole issue is that there is currently no legal treaty able to regulate the lawfulness and the eventual sharing of mining activities.
So that ends part 1 of our talk about establishing a lunar outpost or lunar base. Now in part 2, we shall now listen to this talk about colonizing the red planet Mars. So just sit back and relax and let us now listen to this talk about colonizing the red planet.
So that's the big question now, ladies and gentlemen. Can we colonize Mars? Is colonization of Mars possible? So if you will ask me, the answer is yes. Colonization of Mars is possible. In fact, the colonization of Mars has received interest from the public, from space agencies like NASA, ESA, and private corporations like SpaceX. And the colonization of Mars has received extensive treatment in science fiction writing, in film, and art. So that's how popular that concept of colonizing Mars is. So the first step in Mars colonization would be a human mission to Mars. a human mission to Mars would be the first step towards any colonization effort. So dapat magpadala po muna tayo ng tao sa Mars before any colonization efforts would be possible. Okay? So human mission to Mars first. Now again, there are reasons why we need to colonize Mars. Okay, so the first reason would be your curiosity. Okay, we need to colonize Mars because we want to add knowledge of the red planet. Your curiosity to boldly go where no man has gone before. Okay? Another reason is that the potential for humans to provide more in-depth observational research than unmanned rovers. Okay? Maraming nagawa ang mga unmanned rovers like Curiosity, Pathfinder. So, they have accumulated so much data about the red planet. Pero iba rin talaga pag yung tao mismo ang pumunta sa Mars. Okay? The potential for humans to provide a more in-depth observational research as compared to unmanned rovers. Kasi iba yung talagang umapak ka mismo sa ibang planeta. Okay? Iba yon as compared to sending robotic rovers to the red planet. Okay? Alright, another reason why we need to colonize Mars is the economic interest in its resources. Ayan, so as we are aware of right now, iba yung mga resources natin dito sa Earth medyo nadideplete na. So maybe Mars could be a source of these resources. Ayan, so economic interest in its resources. And another reason for colonizing Mars is the possibility that the settlement of other planets could decrease the likelihood of human extinction. Okay? Finding other worlds. Yan, para ma-colonize natin. Okay? Probably there would be a time, darating yung panahon na the Earth would be uninhabitable because of pollution, siguro, or probably we would destroy ourselves through nuclear war. So the possibility that the settlement of other planets, especially Mars, could decrease the likelihood of human extinction. Okay? As the saying goes, to boldly go where no man has gone before. So these are the reasons why we need to colonize Mars. And the fact that beyond Earth, Mars is the only one of the only places in the solar system where humans could one day live. Now, this notion of colonizing the red planet really became popular because of the fact that Mars is relatively similar to Earth. Mars and Earth are similar in several ways. Okay? So, one similarity between Earth and Mars would be the duration of its day. Now, here on Earth, one day is 24 hours. But a Martian day or sol is about 24 hours and 40 minutes. So, sobra lang po ng 40 minutes sa Mars. The Martian day or sol is very close in duration to Earth's. A solar day on Mars is 24 hours and 40 minutes, which is really close to Earth. Kasi po ang Earth natin ay an Earth day is 24 hours. Okay? So that's one similarity between Earth and Mars. Okay, also Mars has an axial tilt of 25.5 degrees, similar to Earth's 23.44. Okay, so malapit lang po. 23.5 yung tilt ng axis natin as compared to Mars. The Mars has an actual tilt of 25.19 degrees. So halos magkalapit lang po. And as a result of this, Mars has seasons, much like the Earth. And we observe the changes in seasons on Mars by observing the shrinking and growth of the polar ice caps. So pag malaki yung polar ice cap sa Mars, that's equivalent to a Martian winter. Pag maliit yung polar ice caps, that is equivalent to a Martian summer. Okay? So because of this similarity in the actual tilt between Mars and Earth, Mars has seasons much like the Earth. Okay? Alright. Another similarity would be the presence of water ice. So observations by Mars rovers and orbiters detected the presence of water ice on Mars. So malaki yung possibility po na may tubig sa Mars. And there are geologic evidence that water once flowed on the red planet. Kasi di ba may mga na-discover sila mga geological features that resemble dried up riverbeds. And as we mentioned also in episode 1, water is locked in the polar ice caps of Mars. Okay? Alright, and everybody look at this photograph taken by Viking. So again, it's obvious that the Martian terrain resembled that of a desert. Parang yung mga desierto natin dito sa Earth. Okay? So very similar po yung Martian terrain saka yung terrain natin dito sa Earth. So look at the Martian terrain, ladies and gentlemen. The Martian terrain really is similar to our deserts here on Earth. Okay. So those are some of the similarities between Earth and Mars. Now, it's obvious that Earth is also different from Mars. Okay, Mars is different from Earth in several ways. So one would be the atmosphere. Now, our atmosphere is over 100 times denser than the Martian atmosphere. Okay? So, mas makapal po ang atmosphere natin as compared to the Martian atmosphere. The Earth's atmosphere is over 100 times denser than the Martian atmosphere. Okay? Another difference would be the gravitational pull. Now, because Mars is smaller and less massive as compared to Earth, the Martian gravity also is less as compared to Earth. So if you weigh about 100 pounds on Earth, he would weigh only 38 pounds on Mars. Di ba po? So pag gusto niyo magbawas ng timbang, imbis na mag-exercise po kayo, pumunta na lang po kayo sa Mars. Okay, so if you weigh 100 pounds here on Earth, you would weigh only 38 pounds on Mars. Okay, so that's a difference in terms of the gravitational pull. And also, in relation to the gravitational pull, on Mars, you would experience about 62.5% less gravity than you're used to here on Earth. So kung dito sa Earth nakatalon kayo, like the one in the illustration, pagdating nyo sa Mars, you can do kangaroo hops, mas mataas po yung talon ninyo. Because the gravitational pull on Mars is less as compared to the gravitational pull here on Earth. Okay? So mas magiging mataas po ang talon ninyo sa Mars. Okay, so pwedeng-pwede kayong mag-basketball sa Mars. makakadunk po kayo. Okay, and another difference between Earth and Mars would be the temperature. Now, since we know that Mars is farther from the Sun as compared to Earth, so that means Mars is receiving less heat from the Sun as compared to Earth. So that means malamig po talaga sa Mars. In fact, the coldest temperature recorded on the Martian surface is negative 125 degrees Celsius as compared to the coldest recorded temperature here on Earth, about negative 92 degrees Celsius. So talagang malamig sa Mars. Okay? It's even colder than Antarctica. Okay, and you combine that with the Martian terrain. That's why the Martian terrain is described as a frozen desert. Okay, so those are just some of the differences between Mars and Earth. Okay, so at this point, we have mentioned the similarities and differences between Earth and Mars. So the question now is, now how do we go to Mars? So the first thing that we need to consider would be the transportation. Okay, so we need to consider this for our journey to Mars. Kung paano tayo pupunta sa Mars, so we need a form of transportation. Now, a trip to Mars requires about 7 months in space. So medyo matagal po yan. A trip or a journey to the red planet requires approximately 7 months in space. Okay, so medyo matagal po yan. So we need to shorten the travel time again because we all know some of the perils or dangers of interplanetary space flight, like the effects of microgravity in space, the effects of radiation. So we need to shorten the travel time at least below 7 months. So pwede na po mga 4 months on our journey to Mars. At least 4 months na lang po as compared to 7 months. Masyadong matagal po yung 7 months. So shortening the travel time below 7 months would require increased amount of fuel for our chemical rockets. So medyo medyo duda tayo dyan because if you increase the amount of fuel, mas bibigat po yung rocket. And that's a problem. Okay? But that's one way of shortening the travel time below 7 months. So we increase the fuel for our chemical rockets. Okay? And NASA is now working on this vehicle called Orion. Okay? The Orion is much bigger than the Apollo spacecraft. If you will look at the diagram, so yung Orion spacecraft is similar to the Apollo command module. Kaya lang mas malaki po ito yung Orion. Alright, the Orion is bigger as compared to the Apollo 11 command module. Even yung service module ng Orion medyo malaki as compared to the service module of the Apollo spacecraft. So everybody look at this diagram. So we have here a comparison between the Apollo spacecraft and the Orion spacecraft. Yan, so medyo malaki tong Orion. So this Mars spacecraft must be lifted by a heavy rocket. Dapat mas malaki yung rocket nito as compared to the Saturn V. So the Orion spacecraft will be carried by the Space Launch System or SLS. So NASA is working on this heavy lift vehicle, the SLS. Alright? Okay. Now, a trip to Mars, as I have mentioned, requires 7 months in space. So shortening the travel time also involves using advanced spacecraft propulsion technologies, some of which have already been tested to varying levels like the variable specific impulse magnetoplasma rocket and nuclear rockets. Now, these new technologies are now being tested by NASA and several private corporations. Okay, so here is a diagram of a nuclear rocket. Now, the propellant is hydrogen. The hydrogen is pumped in a nuclear reactor. Inside the nuclear reactor, a chain reaction occurs, and this chain reaction of atoms produces hot gases, which is then ejected through the nozzle. So fantastic, isn't it? So this technology is now being tested by NASA and several private corporations. So that's a nuclear rocket engine. So hopefully in the future, nuclear powered rockets would take their journey to the red planet to shorten the travel time. Sana kung 7 months, mapaiksi yung travel time to 4 months lang because of these nuclear powered rockets. Okay, and this was depicted in the movie The Martian. Yung mothership nila, it's called Hermes, and this mothership is powered by nuclear rockets para mas shorten po yung kanilang journey to Mars. Okay, so that's a nuclear powered rocket which was depicted in the movie The Martian. Alright, and if you will notice, the Hermes rotates. This rotation produces centrifugal force, and this centrifugal force is equivalent to an artificial gravity, because we all know that there are some effects of microgravity in space to the human body. Yan, so umiikot yung Hermes. Alright, and also in our journey to Mars, we should also consider the moon. Okay? Kasi mahirap po mag-construct ng rockets dito sa Earth pa manggagaling. So, if we can construct the Mars spacecraft sa moon, mas madali po siya. We can make the spacecraft larger to accommodate more astronauts. So, the moon is said to be our gateway to the red planet. Okay? So, the exploration of Mars, we would be needing the moon. Okay? Alright, so the moon is said to be the gateway to Mars. Now, once the spacecraft reaches the red planet, there are many challenges that the astronauts must face upon reaching the red planet. So this includes radiation, temperature, low oxygen or no oxygen at all, the lack of food, the lack of water, the lack of fuel, the atmospheric pressure. They have to deal with that because we all know that the Martian atmosphere is thin, so that is tantamount to a lesser air pressures compared to Earth. And the time delay, we have mentioned this in episode 2, the communication time delay, and the Mars habitat. So these are just the challenges that these Mars explorers must face upon arrival to the red planet. Okay? Now, let us now tackle on this issue of human habitation on Mars. Now, what are the conditions for human habitation? Now, we have to consider that the surface of Mars is not hospitable for humans or most known life forms. This is due to what? This is due to radiation. Now, we all know that Mars has no oxygen, so no ozone. So the Martian surface is bombarded with deadly radiation from the sun. Also, they have to deal with greatly reduced air pressure and the atmosphere, which is only about 0.16% oxygen. See? So the surface of Mars is not hospitable to humans or most known life forms. So we have to consider that. Okay? So human survival on Mars would require living in artificial Mars habitats with life support systems. Okay? So ito po yung kailangan in order to colonize Mars. So human survival on Mars would require living in artificial Mars habitats with complex life support systems. Okay, so what are these examples of complex life support systems? So one example would be the recycling of water or water processing systems. Now, through experience and training, astronauts on board the International Space Station or ISS have shown that it is possible to use far less water and that around 70% of what is used can be recycled using the ISS water recovery system. So anong ibig sabihin nito? Yung mga astronauts po sa ISS, they use less water kasi limited po yung water supply nila. And yung 70% na nagamit nila is recycled. So that includes urine. So yung mga ihi ng astronauts, they recycle it. Meron silang complex filtering machine on board the ISS to filter out urine. So naiinom din po nila yung urine nila. See? So that's the water processing system on board the ISS. So kailangan po ito in a Mars mission because of the limited water on their 7-month journey to Mars. They need to use less water and, if possible, recycle the water that was used, including their urine. Okay? Fantastic! Isn't it? Diba? Okay. In the ISS, they make use of less water. So kung pwede, magtipid po sila sa tubig. And yung 70% na nagamit nila must be recycled. And that includes their urine. Okay, so another example of a life support system that is considered in colonizing the red planet is the generation of oxygen. Okay, there must be a way to generate oxygen on the Martian surface. Alright, and I'm sure you are aware of the Perseverance rover on its way to the red planet. And on board the Perseverance rover or the Mars 2020 rover is a special equipment called MOXIE or Mars Oxygen ISRU Experiment, in short MOXIE. Now MOXIE is an instrument that seeks to turn the atmospheric carbon dioxide on Mars into oxygen to be used as propellant and life support. Okay? Now, MOXIE is a payload being developed for NASA's Perseverance rover or Mars 2020 rover and will produce oxygen from the Martian atmosphere through the process known as solid oxide electrolysis. Okay? Alright, so here is a simple diagram of what MOXIE can do. So MOXIE will absorb the carbon dioxide from the Martian atmosphere. So you can see that yung intake. So MOXIE will absorb the Martian atmosphere containing carbon dioxide, and this carbon dioxide will undergo solid oxide electrolysis. So there are electronics on board MOXIE that will utilize this process known as solid oxide electrolysis. So parang electrolysis po yung, I'm sure you're familiar with this, yung separation of hydrogen and oxygen from water through a process known as electrolysis. So water is separated into hydrogen and oxygen. Ito po, similar po ito. So we know that carbon dioxide is composed of 1 part carbon and 2 parts oxygen. So ihiwalayin po yan yung carbon from the oxygen through this process. So ang lalabas sa MOXIE is oxygen, yun, and carbon monoxide. So nabawasan po siya ng isang oxygen atom. Okay? Fantastic, isn't it? So this is how MOXIE works. So converting atmospheric carbon dioxide and this carbon dioxide in the Martian atmosphere undergoes solid oxide electrolysis, separating carbon from oxygen. Okay, so that's one way of generating oxygen. So this is now on board the Perseverance rover. Fantastic, isn't it? Wow! Pag natuloy po ito, the colonization of Mars would be on its way because there's now a way to generate oxygen on the red planet. So that's MOXIE. Okay? Alright. So that's really something to look forward to. Okay, so once the Perseverance rover lands on the red planet and when MOXIE is activated, yan, makikita natin if MOXIE can really convert atmospheric carbon dioxide into oxygen. Now, in colonizing the red planet, we need to consider the effects on human health. Now, in colonizing Mars, we need to consider the effects of gravity. Now, the difference in gravity would negatively affect human health, because we all know that the Martian gravity is less as compared to gravity here on Earth. Now, this difference in gravity would affect human health by weakening bones and muscles. And there is also the risk of osteoporosis and cardiovascular problems. And they are now studying the effects of this difference in gravity in the International Space Station. Now, we mentioned in episode 2 that one of the effects of microgravity would be the deposition of calcium in our bones. So there is a decrease in density. So may bone loss because of microgravity. So lumalambot po yung buto natin. And as a result, osteoporosis occurs, okay, because of this microgravity. So what more sa Mars? Because of the less gravity on the Martian surface, yun, magkakaroon po ng less deposition of calcium in our bones. So as a result, you will have osteoporosis. So it is reported that 3.2% of bone loss occurs after 10 days of microgravity. So na-experience po nila yan sa International Space Station. It is not known how much of this bone loss is recoverable after returning to Earth, although it is probably not 100%. So talagang naka-apekto po sa mga buto natin yan. So these changes in bones may limit the duration of space flights. So dapat hindi po matagal ang journey sa Mars. Kung pwede po natin mapaiksi from 7 to 4 months. Again, because of the danger of osteoporosis for our astronauts. Also in microgravity, you do not use the muscles that help you stand and maintain posture. Kasi nakalutang po sila, especially sa ISS. Okay, so during extended space flights, about 20% of the slow twitch become fast twitch fibers which are smaller in size. So ang ibig lang po sabihin nito, because with the astronauts, they don't use their muscles kasi nga lumulutang lang po silang ganyan. So muscle atrophy may occur. So lumiliit po yung muscles. Kasi hindi naman po nila ginagamit yung muscles to maintain posture. Yan. As you could see here, lumulutang po sila para silang Superman na lumilipad. Diba? So this may result to a decrease in muscle mass. Okay? And also the one effect of microgravity would be in the circulation of our blood. Now due to microgravity, blood shifts away from the legs and blood moves towards the head. Ganun po. So hindi rin maganda po yan because of microgravity, there would be less supply of blood in the lower extremities. Okay? And again, like what I mentioned, because of microgravity, there would be a decrease in muscle mass. So paano yan? On the 7-month journey to Mars and the less gravitational pull on the Martian surface. Now, in the ISS, to minimize the effects of microgravity, nag-exercise po sila. As you could see here, itong astronaut na ito, nag-exercise po siya to minimize the effects of microgravity in the International Space Station. So, in our journey to Mars, yung 7-month journey natin sa Mars, the Mars astronauts would require also this activity. So dapat nag-exercise din po sila on their 7-month journey to Mars. And pag nasa Mars na sila, they also should do the same. Kasi yung gravitational pull sa Mars is less as compared to the gravity here on Earth. So ayan po, yun ang ginagawa sa International Space Station. The astronauts are required to exercise at least 3 hours a day. Okay, to minimize the effects of microgravity on bones and muscles. Okay? Yan, fantastic, isn't it? Diba? So, nag-exercise po yung mga astronauts on board the ISS. So, the Mars astronauts must do the same thing on their 7-month journey to Mars. So, it is very important for astronauts to exercise at least 3 times a day in order to minimize the effects of microgravity on bones and muscles. Okay, so another thing that must be considered for a manned mission to Mars is exposure to radiation. Now, Mars has no global magnetosphere as Earth does. So, what does this mean? Now, Mars is not surrounded by a magnetic field. Unlike our planet, the Earth is surrounded by a magnetic field. The Earth is a giant magnet, and this giant magnet surrounds us with a magnetic field, and this magnetic field protects us from harmful radiation from the sun. Now, Mars has no magnetosphere, so no magnetic field, plus the fact that the Martian atmosphere is thin, so a significant amount of ionizing radiation penetrates the Martian surface. Okay, so the surface of Mars is bombarded with a significant amount of ionizing radiation. So, radiation bombarding the body of an astronaut can increase the risk of getting cancer. So, yan po, kasi wala naman pong magnetic field sa Mars to protect it from radiation. So, the astronaut is constantly bombarded with radiation, and this will increase the risk of getting cancer. Alright, so what is now the solution? Now, the only solution would be heavy shielding. So, heavy shielding amounting to about 15 centimeters of steel. So, makapal po yan. Or 1 meter of rock. Or 3 meters of water. Limiting human colonies to living underground practically 100% of the time. So, anong ibig sabihin po nito? So, ang habitat, the Mars habitat, must have a shielding of about 15 centimeters of steel. So, dapat makapal po ang shielding to protect the astronauts inside the habitat from deadly radiation from the sun. Okay, or the habitat must be constructed underneath the Martian surface. So, sa ilalim ng lupa, i-construct yung habitat to protect the astronauts from deadly radiation from the sun. And even the spacesuit must be properly shielded para maprotektahan po yung mga astronauts from radiation. So this is a very important aspect to consider for a manned mission to Mars, the exposure to radiation. Okay, and lastly, a manned mission to Mars should consider the psychological effects on the crew. Now, due to the communication delays, we mentioned this in episode 2, that a one-way radio message from Mars to Earth would take about 13 minutes. So, that means that the Mars astronauts must wait 26 minutes for any reply from mission control. So because of this, new protocols need to be developed in order to assess crew members' psychological health. Kasi di ba po, pag matagal po mag-reply, nag-aalala po mga astronauts pag matagal po yung message. Especially pag may nangyaring masama in the habitat, the Mars habitat. So this is important, yung psychological health ng mga astronauts. Alright? So, scientists should consider the psychological effects of isolation, repetitive tasks, and living in close quarters with other scientists for up to a year at a time. So, very important po ito, isolation. Yan kasi ang feeling po ng astronaut, nag-iisa na lang po siya sa planet Mars. Kasi ang layo ng planet Mars sa Earth. So yun ang magiging feeling ng mga astronauts, a feeling of isolation. And also repetitive task, yung paulit-ulit po na trabaho nila. Nakakabaliw po yun, di ba? Paulit-ulit na lang lagi. And living in close living quarters. So kasama niyo po yung mga scientists up to a year. Di ba parang quarantine po ang mga astronauts. Kung tayo nga po, di ba? We have been in quarantine for several months already. Diba? Nasa bahay lang tayo because of the coronavirus pandemic. So, diba nakakabaliw po yun? Several months po tayong nasa bahay. Diba? That will affect the mental health of the people in quarantine measures na yan. What more for a manned mission to Mars? So, more than a year po sila nasa habitat. Okay? So, the psychological health of the astronauts must also be considered. Okay, like in the movie The Martian, di ba? Naiwanan si Mark Watney. So, he felt isolated sa Mars. Nag-iisa lang po siya sa Mars. Okay? So, because of his attitude of not giving up, Mark Watney was able to solve problems one at a time. Then, eventually, nakauwi din siya sa Earth. Okay? So, scientists must consider the psychological or mental health of the Mars crew. Now, before we end, I just would like to share some life lessons from the movie The Martian. This movie is really one of my favorites, and this movie really features many concepts that are possible for a manned mission to Mars. And aside from the scientific aspect of the movie, there are several life lessons that we can learn from this movie, The Martian. Now, one important life lesson that we can learn from this movie is hardships can come anytime. So it doesn't matter who you are or how old you are or whether you are rich or poor. Now, when hardships come, they come knocking, and all we can do is be prepared, even if that sometimes we are just caught off guard. Okay? So, kahit na mayaman ka or mahirap, matanda ka or bata, yan, dumarating po sa buhay natin yan. Okay? So, dapat lang maging handa tayo, pero most of the time, we are caught off guard. Like, itong nangyari sa atin po ngayon, di ba? Itong pagdating ng coronavirus pandemic. So, hindi po natin inaasahan to. And, frankly, we are not prepared for this. Di ba? So, kahit bata ka o matanda, mayaman ka o mahirap, if you are inflicted with the virus, then that's it, di ba? Okay? And ngayon po, because of the lockdowns, yung mga quarantine protocols, maraming nawalan ng trabaho. Okay, yung iba po namamalimos na, especially yung mga jeepney drivers. So, yan, hardships can come anytime. So, all we have to do is be prepared and pray, di ba po? Like what happened to Matt Damon's character, si Mark Watney. So, the same happens to Mark Damon's character, that's Mark Watney, in the movie as well. So, everything was going well for the crew on Mars, and suddenly, due to a stroke of bad luck, Mark Watney, played by Matt Damon, was separated from his team and was stranded alone on the Red Planet. So, if you will recall in that scene, di ba nagkaroon po ng dust storm and Mark Watney was injured. So, naiwanan po siya ng kanyang crew. Bumalik po yung crew sa mothership, then bumalik sila sa Earth. And Mark Watney, played by Matt Damon, was stranded. So, yun ang paghihirap niya. So, marami siyang paghihirap while he was alone on the Red Planet. Okay? So, hindi niya inaasahan yun na may stranded siya. He would be marooned on Mars. So, ganyan din po sa buhay. So, hardships can come anytime. Okay? So, basta lang ho, kapit at hindi tayo mag-give up. So, hardships can come anytime. So, that's our first life lesson from this movie, The Martian. Hardships can come anytime. Okay? Now, the second life lesson that we can learn from this movie, The Martian, is don't give up hope. So, when hardships come, it is easy to give up hope, and it is the first thing that people usually do. Diba po, pag may dumating na pagsubok sa buhay natin, susuko na kaagad tayo, ay, ayoko na. Ang hirap naman nito. Okay? So usually, yun ang ginagawa po natin. That's because most of the time, they are simply not expecting it, and it hits them hard. Okay? So, the same thing happened to Matt Damon's character, Mark Watney. Okay, so, hindi siya sumuko. Alright? So, even though he was marooned on the Red Planet, hindi siya sumuko. He survived his ordeal. So, limited food supply, nagtanim siya ng patatas, and he tried his best to communicate to his crew. Okay, so gumawa siya po ng mga ways para makipag-communicate siya. Alright? Watney was left stranded alone on an entire planet. Yet he didn't give up hope, di ba? Hindi sumuko si Mark Watney. Nagtanim siya ng patatas, hinanap niya yung Pathfinder in order for him to communicate to his crew and mission control. That is the first step. Okay, it is literally telling your brain that something can be done. So, may mga paraan na pwedeng gawin like yung mga ginawa ni Mark Watney. And that's where you start to turn things around, di ba? So like limited yung food supply niya. So nagtanim siya. And in terms of communication, he tried to locate Pathfinder, yung robotic rover. And he communicated with his crew and mission control. Okay? That something can be done. So never give up hope, ladies and gentlemen. So ito, kahit nasa pandemya po tayo, we are still hoping for that vaccine. Okay? Alright. So, yan, nagtanim po siya ng patatas. Talagang hindi sumuko si Mark Watney. And he tried to locate yung Pathfinder so that he can communicate with the mission control and his comrades dun sa Hermes. Alright? Okay. And also, another important lesson from the movie, always bring duct tape. Duct tape works anywhere. Yan. So, napaka-mahalaga itong duct tape. Even the Apollo astronauts, yung Apollo 13, meron po silang dalang duct tape. Okay? Diba, if you will recall, diba, nagkaroon po ng accident sa Apollo 13. The oxygen tanks exploded. So, buti na lang may duct tape yung mga astronauts. So, they were able to figure out ways to solve certain problems. And nagamit po nila yung duct tape. And this was featured also in the movie The Martian, yung paggamit ng duct tape. Okay? Like there was a scene na basag po yung salamin ng helmet niya. So, nagkaroon ng decompression sa spacesuit. So, anong ginamit niya para matagpian niya yung crack dun sa helmet? Well, you got it. Duct tape. O yan, di ba? Then, yung na-decompress po yung habitat, di ba? Sumabog po yung pintuan. Then, nasira po yung mga halaman niya. So, anong ginamit ni Mark Watney to fix the auto door of the habitat? Well, you got it. Duct tape. So, duct tape is magic. Okay, so dapat yung mga Mars astronauts must bring duct tape with them. Okay, guys. So, I guess that's it for episode 3. Okay? So, episode 1, we have studied man's fascination of Mars. In episode 2, we have studied man's exploration of Mars. And this episode 3, we have tackled how we can colonize the red planet. So, are we ready to go to Mars? So, tara na. Let's go to Mars. Okay? Alright, so after Mars, then what's next? So probably the next step now is the moon. So we must colonize the moon first. We must establish a lunar base. Then from there, we can assemble the Mars spacecraft. Kasi mas madali po yung less gravity and walang atmosphere. So we can assemble a Mars spacecraft on the moon or lunar orbit. Mas malaki po yung Mars spacecraft if it is assembled on the moon. So they can carry more fuel, more food, more oxygen, and more crew. Okay, so in my opinion, that's the next step. Okay, we must first establish a lunar base. Then from there, we can proceed to a manned mission to Mars. Like what I mentioned in this talk, that the moon is our gateway to Mars. Okay? Alright, so again, I will leave you with this quotation mentioned by Carl Sagan. So, the sky calls to us. If we do not destroy ourselves, we will one day venture into the stars. Alright. Okay, so that's Carl Sagan, my idol.
Well, I guess that's about it for this episode entitled Spacefarers. So if you have any questions or comments or reactions about our online lecture this evening, please feel free to type in your queries in our comment section below. Wag po kayong mahiya and we would be very happy to respond to your questions. Shout out sa mga students ko from 11 and 12 STEM and shout out sa mga suki natin dyan na mga ka-spacers na laging nakatutok sa ating programang Space, the Final Frontier. Sana wag po kayong magsawa sa panunood at pagtutok sa ating programa. Kaysa manood po kayo ng teleserye sa TV, dito na lang po kayo tumutok. So, this is your ka-spacer, Professor Jun Cajigal, saying, live long and prosper, and I will see you in our next episode of Space, the Final Frontier. So stay safe, everybody, and goodbye. See you in our next episode.
It's one small step for man, one giant leap for mankind.
Choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.